All right, welcome. This is the workshop with Biohm and Materiom, and I'm hosting this session. My name is Marita Sauerwein. Before we start, I first have a general announcement from Ken. He'd like to let us know that there is a special session from the Ellen MacArthur Foundation at 18 to 1930 CEST, where you can meet the foundation team who knows a lot about matrix and research. And there is a link to this session which can be found in the link can be found in the members area. So it's for affiliations and full members. So that for now, and then we can go to the general session, which is with Ehab Syed from Biohm and Alysia Garmulewicz from Materiom. They will introduce themselves and give a short presentation about their work, and afterwards we have plenty of time to ask questions. So please ask these questions in Menti. Please, Alysia, I give the floor to you.
Thank you very much, Marita. And I'm just going to share screen now and go to our presentation. Okay. Pardon me. Okay, can you see the presentation?
Yes.
Perfect. So my name is Alysia Garmulewicz, as Marita said. I'm a professor of circular economy at the University of Santiago in Chile. The work that I'm going to present is a not-for-profit that is my applied area of research, together with a large distributed team in many parts of the world. And our platform is called Materiom, and we call it Nature's Recipe Book. So I'm going to discuss both what we do at Materiom, as well as how it relates to themes in the circular economy in terms of research and practice. So the inspiration behind Materiom is to start with imagining our materials as nutrients. And principally, we look at the natural world as inspiration. So if we imagine a forest, an ocean, all the biomass around you, it's a vast and continual production of materials. And so we have to think of the natural world as producing materials to begin with, but yet forests have no landfill, the ocean no wastewater. And for billions of years, plants and animals have evolved to make materials with particular set of ingredients that organisms know how to source, use, break down, and use again. And this is our jumping off point for Materiom. How can we take these building blocks and make them into the materials for human use and human industry? Our mission is to enable everyone everywhere to participate in this next generation of circular materials. And so these materials are not just for the select few or select companies. We envision a world where small local enterprises, as well as medium and large scale enterprises, can also produce materials in a way that is producing high-tech materials, but also made from local building blocks. And so how do we do this? Our model is a recipe library for starters. The idea of decentralizing and opening up information about materials is at the core of Materiom. So we see that the key to accelerating development and innovation in the materials space is to, one, invest in open source recipes. So on our platform, you'll be able to see an open library of literally how to make a material. So this is bioplastics, biocomposites, and these are all materials made from locally abundant sources of biomass. For example, cellulose, starch and proteins, natural fibers, common minerals and clay. And it's not only open source, but community driven, so that anyone can contribute to this recipe library. The second part of our model is a data sandbox, and we call it a sandbox because we want people to play with the data on these materials, the properties that make these materials have certain performance characteristics for different product niches. And this is actually what we're working on right now. It's not present on the platform, but in the next month or so, we'll be demoing the database, the data sandbox for the first time. And users will be able to benchmark our materials against those in the market and select promising alternatives for further research and commercialization. And finally, the third pillar of our model is community. So we're developing hubs, and they're actually quite organic in the sense that hubs have often approached us as centers of regional expertise, where we can run workshops, develop local materials specific to the biome or the ecoregion that surrounds that hub, and work together across hubs to on collective material challenges. And one of the beauties of this set of building blocks that we work with, which are the building blocks that the natural world works with, is that they're everywhere. And so not only can you customize materials to your local set of biomass, but you can also share recipes because they are customizable pretty much anywhere in the world. And so some of our community hubs we have in Boston, London, Santiago, and Valdivia in Chile. And there's a couple of nascent ones in the UK happening as well outside of London. So I'm going to now go to a demo just to give you a sense of our platform in action. And this is our library as it currently is today. So there's, you know, always recipes that are coming onto the platform in a continual fashion. You can select for ingredients or recipes. We're going to look at 3D printed ones today because Marita is on as our moderator. I thought it would be a nice example of some of the work that has been done. So Marita is the lead author on this work. And as you can see, it's a how to make a mussel composite material made with alginate. You can see the ingredients that you need: mussel shells as the source of calcium carbonate in this sense. Alginate is a biopolymer isolated from the cell walls of seaweed that can be pretty much harvested in a huge number of locations all over the world. And these are the steps for making it. And this is actually a 3D printable one, which is a really nice example of the type of processes that you can then customize your recipe to. So the team that we have, I won't go through everybody, but we have a team that is in various parts of the world, and this is actually a small subset of it, to be honest. There's a lot of people who are now contributing their time, their resources in developing our model in local hubs, but also as a global coordinated team. And here's some of our supporters, many of whom, including, for example, the Ellen MacArthur Foundation, are here in the UK. And current projects we're funded by the European Commission. This is a really interesting project where we're developing biomaterials from waste sources, abundant sources of waste such as food waste, textile waste, construction waste across 6 European cities. Exemplar, we worked with the Exeter University over the last 2 years to look at biomaterials from local sources of biomass from the Exeter region. And the seaweed bioplastic we're developing at the University of Santiago on the basis of local abundance on the coast of Chile, and looking at a variety of different variations on that recipe to look at various performance metrics in plastics packaging. PolyML is a machine learning project that we're partnered with the University of Oxford on, basically to use best-in-class advanced methods in materials discovery for the biomaterial area, and that will interface directly with our data sandbox on material properties. And finally, a project with the National Institute for Standards and Technology in the US, as well as the Center for Bits and Atoms, MIT, on material measurement devices, which I'll talk a little bit more about later. Motivation and impact, these are the themes that tie to the circular economy. So we are very much in the biocycle, as one can imagine, in terms of using these basic building blocks, proteins, carbohydrate building blocks that other organisms can break down and repurpose. And the aim there is to actually enrich rather than degrade natural systems, of course, but look into methods for sourcing and cycling biomass at local and regional scales that can enhance biodiversity in a region. So that's some of the ongoing research that we have. The second theme is around resilience. So the idea of increasing adaptiveness of the economic system through investment in local and regional supply chains is a theme that in our current times with COVID is writ large, with the idea of the need for adaptiveness, the need for resilience when shocks to the system come are readily apparent now. And the idea of investing in more local, renewable sources of materials really makes sense from a number of angles, not the least from the sustainability circular economy angle. And finally, accelerating innovation. This is our aim of the open source play, so to speak, in this space, is that we think by providing a platform that can crowdsource innovation and combine research hubs with an open source community-driven approach, we can provide a data layer and an information layer that can accelerate the R&D process for players all over the world who want to get into the biomaterial market. That may include companies who want to open a new product line, or it may include entrepreneurs who are entering the materials market for the first time. And that data layer can get you going. It can basically shorten that R&D cycle by virtue of providing the key bits of information, the starting point, the recipe to get you going. A little bit on roadmap. So our recipe library, we're a very new organization, a couple of years old now. Library development, we're going to be working more with published data and student projects from the research side, and having those be a core part of our recipes on the platform, similar to what Marita has shown. User-driven applications, we're going to be working a lot with designers, the design community, to take our recipes and then adapt them for specific product design applications, and then show those on the platform as well. So you can imagine browsing a material and then seeing all of the various ways that designers have used that recipe for specific products. So we want to get away from this idea that, you know, one material is for one product application, but rather they can be customized, adapted in certain ways via process variation or compositional variation for a specific product niche of interest. Eco-regional connections, that's the collections. That's where we're similar to the Exeter project. We're looking at what makes sense in a certain eco-region, and when eco-regions have certain types of biomass that are actually quite similar. For example, in Santiago, Chile, we are very similar to the Mediterranean biome, which is our eco-region. So understanding what recipes may be locally appropriate also involves global linkages between eco-regions of similar nature in terms of flora and fauna that are common. The second part of our roadmap is the data sandbox, and this is where a huge amount of our effort currently is focused on. So providing data sets where you can look at the ways that you can adapt, say, seaweed bioplastics we're working with right now. You can vary the composition, so the percentage of the biopolymer or the plasticizer or various, you know, ingredients. If just changing the percentage changes the performance of the material massively. And so what we're doing is quantifying all of those variations so that you'll be able to, for a specific, say, packaging application that you need a mechanical strength or elasticity or elongation, these are kind of common metrics that you need to know if you're going to, you know, develop a product. You'll be able to see, okay, I want to use this set of building blocks, this recipe, and it'll get me this performance that I need. The design aspect of this is actually providing some guidelines for creating custom materials for product designers. So the idea of democratizing this information is at the heart of it. And we also want to enable, as I said, more production. So the goal is to provide that data layer for R&D processes. So it's selection, design, and production. Those are the three angles that we want the data sandbox to serve. And the other part I'll mention is that in terms of data analysis, we're going to be embedding a lot of these machine learning tools into the data sandbox so that combining experimental data where we've actually tested on machines, the various properties of the material, with data sets that are experimentally derived. You can actually then expand the formulations you can calculate by virtue of these machine learning models. So generative models, for example, given a set of data, you can say, okay, what about this formulation with a specific process and set of percentages of ingredients that wasn't experimentally tested? The machine learning model can actually extrapolate and give you a prediction on what the properties would be. And then we can use that formulation, if it's of interest, and experimentally test it. So we're using machine learning to expand the range of data and close the loop between calculation, experimentation, and prototyping. The final piece of the puzzle is data generation. So how do we get those data sets to begin with? We are, of course, working with research organizations such as my university and others to generate those data sets, but we envision that materials data is currently at a bottleneck. That's currently where it's at. But we envision expanding the community that can produce data massively through open source technology for materials testing. And this is a project that we're running, that we're collaborating with MIT on, to develop, say, an Instron, which is a universal testing machine, a brand for a universal testing machine that's super common, but quite expensive, an open source Instron that can do mechanical property testing, for example, others that can do rheology, and the point is to create some downloadable designs for the community of digital fabrication spaces in the form of maker spaces, fab labs, etc., who work with materials and production all the time, but can now enter the game in terms of developing their own materials and testing them, and contributing data in the process. And we're actually looking at some high throughput machines as well for generating a lot of different variations on a material and contributing that data as well. So that is the close of my presentation. I will welcome questions after Ehab's presentation, and I'd love to discuss any and all of the themes that I mentioned. And again, appreciate very much me having the time to speak to you all, and I hope it was intriguing and start some good conversations. So thanks so much.
Thank you, Alysia, for this nice explanation of Materiom. Yeah, you can post questions in Menti, so go to menti.com, and the code is in the front page of the website, is4ce.org, so please do that. And then I'd like to give the floor to Ehab.
Hello, thank you very much for that. Really fascinating talk from Materiom. I'm just going to share the screen quickly. Right. Can everyone see that okay?
Yes. Yes, or it's a bit blurred. Is
that better?
Yeah.
Right. Good afternoon, everyone. I'm Ehab Syed, and I'm the founder and director of innovation at Biohm. I'm also a PhD researcher at Northumbria University. Today, I'd like to talk about how nature can inspire us all to revolutionize the built environment. But first, I think it is now clearer than ever that our capitalist economies are simply not working, and most importantly, they are not working for the majority of the world's population. The pandemic has revealed multiple flaws in our current systems, and it also showed us that capital can be made available in a blink of an eye to support those with power and influence. By being forced to stop almost everything and stay at home, we are collectively and critically questioning our consumption habits, our production practices, and the way we do business. We look around us and we see that we have contributed to a planet in pain, characterized by the scars we've left upon the geology of the Earth. As well as the onset of the sixth great extinction, this has become known as the Anthropocene. Whilst we once lived our lives as part of the natural world, the world we've built for ourselves is marked by a form of extraction and consumption that is changing the world around us. The land, the air, the water is saturated with pollution, and the world is hotter than it has been for 120,000 years. With the population of the planet predicted to increase by nearly 40% in the next few decades, the demands placed upon the world have far exceeded the point of sustainability. If the combined infrastructure plans for growing and developing economies are ever to be realized, we will need a further 7 planets worth of resources. Everything is in constant flow, constant circulation in nature, with outputs from one process becoming the inputs for others. Biomimetics is not the simple imitation of natural form, but is the science that is driven by the realization that our most prized inventions exist in more elegant, eco-sensitive, and efficient and effective forms in nature. A deep understanding of how organisms achieve such feats of engineering can shed light on how we can solve some of the world's most pressing challenges. By taking inspiration from nature, we can move away from an extract, make, and use and dispose linear economy, which has a tremendous negative impact on the environment and our health, to one that is more circular, where we ethically source, reuse, or recycle existing resources in our economy and consider the environmental, socio-ethical, and economic impact of a material or product's entire life cycle. And that is exactly what we do at Biohm. Biohm is a research and development-led company that places biological systems at the heart of its inspiration to revolutionize construction and the way we do business. We achieve this through our bio-based materials, our construction systems, and a range of services. We are starting with the most tangible and immediate of these offerings, and that's our materials. I'll start with ORB, or Organic Refuse Biocompound. It is a semi-structured, structural sheet material made entirely out of food and agricultural waste and contains a 100% natural binder that we've developed. It is currently available for use in interior architecture and will soon be available for dry lining in buildings. It outperforms other wood-based sheet materials when it comes to mechanical strength. It is carbon negative, does not contain any synthetic chemicals or toxins, and is highly price competitive. ORB is currently being developed into a plant-based concrete, which would be a serious game changer. Our plant-based concrete will be available within the next 2 or 3 years. We also work with one of nature's most wondrous organisms, mushrooms. We use the root systems, or the vegetative part of a mushroom, to consume a variety of organic and synthetic waste, and the outcome is one of the world's most advanced building insulation materials. We have developed biologically unique species of mycelium, and we have naturally accelerated their evolution to favor particular traits that would improve their mechanical and physical properties, and we trained them to consume a variety of waste streams. We're currently testing our mycelium insulation against industry standards, and we've been blown away by how we managed to achieve thermal conductivity values as low as 0.024, which may not mean very much to most people, but it competes with market-leading synthetic insulation, and in some cases is 2 to 3 times the thermal insulation values of commonly used alternatives. It is naturally fire resistant, as you can see in this video here, where Zoe Loughlin sets it on fire from one side and has an ice cream on the other side, which remains crispy and well after the experiment. When it comes to VOCs, or volatile organic compounds, which are released by materials throughout their life and affect the indoor air quality and therefore our health and well-being, we achieved the highest possible score of A+, making it one of the healthiest materials available. No additives, no chemicals, outperforming almost all other insulation products on the market by simply using nature's genius. Now, last year we had an interesting little discovery in our R&D lab, which led us onto a super exciting journey. You may be aware of mycelium's remediation capabilities, known as mycoremediation, which is a process by which fungi produces appropriate enzymes that break down complex compounds, like plastics, into hydrocarbons and carbon dioxide. We have discovered last year that we have developed mycelium strains that are capable of consuming plastic. The rate of degradation that we were able to achieve was quite significant, and that was quite the revelation. Last year, the Onion Collective, a social enterprise at the vanguard of social action and community business, joined forces with Biohm, and we were awarded the Waitrose Plant Plastic Prize to continue to develop this research and ensure that such technologies have a transformational impact on local communities. This has allowed us to carry out numerous experiments over the last year, where we continue to evolve our strains through a non-intrusive and non-GMO process known as directed evolution, which basically mimics the process of natural evolution in an accelerated lab environment. This has resulted in the development of 3 strains that can successfully consume PU, polyurethane, and PE, polyethylene. You can see here a microscopic image of the plastic being completely consumed by the mycelium strains. Those little dots are the spores of mycelium. Unlike other plastic recycling processes, which can propagate the current plastic crisis, encouraging the production of more plastics, our process eliminates plastic completely in all outputs. So the non-toxic hydrocarbons are stored in the resulting mycelium material, which in itself is a replacement for plastic and other damaging materials, and the carbon dioxide is turned back into oxygen through the process of photosynthesis and fed back into our incubation space, providing fresh oxygen-rich air to the next batch of mycelium, ensuring a completely closed loop in our manufacturing process, resulting in the production facility effectively being a carbon sink. Although our mycelium insulation, which is currently available, is grown on organic substrates, we aim to eventually integrate plastics and other synthetic waste streams from construction, fashion, and other sectors into our production process. Due to the vast environmental benefits and global potential of such technologies, it was essential for us to deliver this to the world in a way that is ethical, equitable, and sensitive to our current economic landscape, at a time where it is needed the most. So we're setting up the world's first community-led biomanufacturing facility with the Onion Collective. Apart from being the first large-scale facility to produce mycelium insulation, another unique aspect of this collaboration is the way it acts as a catalyst for regeneration within a community. From nature, we've developed a business model that allows communities to drive industry in quite a revolutionary way that ensures the regeneration of the local community, environment, and economy. Our first biomanufacturing facility is almost completely built in Watchet, West Somerset, and it will start at a scale of 3,000 square meters of material output, which is around 20 homes worth of insulation per month. And over the next couple of years, will eventually be scaled up to provide around 120 homes worth of insulation per month. At that scale, we would be using up around 150 tons of waste and sequestering around 30 tons of carbon each month. It would provide over 30 new local jobs, and through the equitable distribution of profits, provide a constant income for the community, allowing them to invest in their education, infrastructure, and social action projects. When developing natural materials, obviously they need to be implemented in construction in quite a unique way. So we've developed Triagamy, an interlocking construction system that combines all of our materials and is inspired by the molecular structure of carbon. It does not require any permanent binders or fasteners to create robust structures that can be deconstructed at any stage of their life, allowing buildings to grow, shrink, and adapt to the needs of its occupants and local community. Architects can design any floor plan and still only use our 21 unique components. It reduces build times by 95%, build costs by 70%, and the environmental impact by 120%. It is patented in all continents in over 60 countries, and we aim to launch Triagamy with our plant-based concrete in around 2 years from now. As I mentioned earlier, we want to bring these technologies to the world in a way that is very equitable and sensitive to the local community's needs. And so we've developed a business model that takes into account every stakeholder's needs and also uses waste as a resource that can also provide a revenue stream when it's being collected to supplement the production costs and compete on price when you're working with against other alternatives on the market. We use artificial intelligence as well to help map the industry. This is something that I'm doing in particular with my PhD. And from that, we're able to develop a new way of doing business that is able to actually benefit the masses or the wider population, rather than only benefit the few that are developing the technology or working on it. So although we're going down the route of patenting our technologies, we're doing that in a way where it can be shared with local communities and embrace a sort of more regenerative approach to business and distribute the wealth in an adequate manner. We're working with some of the top universities in Europe. We're also working with some really large multinationals, as well as small businesses and communities. and we've been awarded and recognized by multiple national and global bodies. We've currently got a crowdfunding campaign live on CEDARS, so please check it out through our website or through the CEDARS website, because we're looking to bring as many people as possible together to join this biorevolution and create a biomimetic future that will help improve our time and costs requirements, it will help us improve our resource and energy efficiency, and it will help us really make an impact at a time of climate crisis where we need to start being more restorative and more regenerative rather than simply just not doing harm. And most importantly, it will help us look after our psychological and physiological well-being so that we can be that species that has helped improve and regenerate the health of the planet. Thank you all very much.
Thank you, Ehab, for introducing us to these promising materials. I see that there is also a question for you, and that asks, is it really correct to talk about waste when in reality it is raw materials from their materials you use for your solutions? Do you have any comments on this?
Yes, so I think the concept of waste in general is something that we'd hopefully like to eliminate. You can think of it basically as an excess resource or a byproduct, but we use that language simply because it's what people understand and how people relate to it at the moment. It is definitely a resource, but by collecting that resource from organizations, we're also offering huge carbon savings for them because our process is carbon negative. So it's a more genuine and honest way of creating carbon credits rather than the more conventional ways of carbon offsetting.
Let me see this one. Somebody says, is it not a problem when it comes to a lot of the issues regarding circular economy that the focus tend to focus on manage waste streams rather than focus on how to in a sound way manage research stream? Let it be resources that has been used for a dung beetle. Do you have any comments on this?
Yes, absolutely. So when it comes to managing waste streams or managing resource streams, the emphasis should not be on the management of the waste itself. It should be on the whole life cycle of that resource and how you can continuously extend that lifespan, but also add value at every process and stage of managing that resource. So I think we definitely need to move away from that perception that circular economy is basically a step up from recycling, and it's more about a systemic view of how we manage resources over the long term. I'm sure, Alysia, you'll have more to say about that as well.
Yeah, I'd like to feed on that. One aspect that I think is really important is also the scope and scale of those flows. So when we think about looking to ecosystems and the natural world for inspiration, we have to look a little bit more under the hood to understand how materials flow in webs of relationships. And rather than what we do now, which is often try and recycle things in large quantities in just large closed pipelines of industry relations, nature disassembles and assembles mostly at the local scale, and that is distributed everywhere. So we have to think about building capacity everywhere to do that assembly and disassembly in order to make the whole system much more effective. And so that is a piece that's missing in the kind of systems thinking, which is what Ehab is emphasizing, is that kind of systems lens. We need to think about what's most effective for those assembly and disassembly of nutrients, if we're going to get away from the terminology of waste. And that has to be about understanding flux and the quantity of nutrients that we're putting into any given environment. So to give an example is that one could imagine that just because something is bio-based, it means that you can just throw it anywhere. And well, that is true to some extent in the sense that the building blocks for life are pretty much sourced everywhere. it's about quantity and flux into that environment in terms of what counts as a toxin or not. So eutrophication is a process by which excess nitrogen and excess phosphorus, both of which are nutrients life needs to sustain itself, that excess gets put into river systems or lake systems and causes algae blooms, which can suffocate life down below. That's an overbalance, like that means that the system is not balanced, that nutrients are not being, the quantity and flux is not in the right proportion. And so we need to think in these terms. And the way that that can be facilitated a lot more carefully is if we have these nested cycles of flow instead of these huge, large pipelines of material flow that our current more centralized system is built on.
And Alysia, how do you make sure that people who feed recipes into Materiom understand this system perspective and don't only look at the resources, so think that when they use bio-based resources, it's sustainable by itself?
Yes, that's exactly the challenge that we're working on. And it's something that I would actually frame as an invitation at this stage, because this is a journey that we're on, and we're certainly at the first part of that journey. Part of the ideas that we have that make up that question are specific guidelines that are informed by this kind of ecosystem perspective to get people asking the right questions. So that's the beginning. But then we need guidelines for adapting that to place, because every single eco-regional mix of flora and fauna will have different nutrient balances. And so we need to be working with ecologists and biologists and people who understand and industries in like agriculture, and like anyone who's involved in the bioeconomy needs to be at the table at that local level. And so we need to adapt those kind of global best practice, good questions to ask guidelines down to the local level. And so that's the kind of, those are some of the guide wires that we have. But I would very much invite anyone who's interested in that conversation continuing to get in touch, because this is going to be an area we'll focus on in the future for certain.
Ehab, did you want to say anything on this? And also for your materials, what is currently their end-of-life perspective?
Yes, I completely agree with what Alysia was saying. I think it's really important to appreciate that in nature, the end of life of one nutrient or one resource is not necessarily cycled back into that same resource or that same cycle. It can flow in and out of one cycle into a million other cycles, and its lifespan is then extended tremendously. So when we look at the end of life of our materials in terms of the sort of hierarchy, our number one approach or our number one solution is to cycle it back into the same production process or another production process that will allow it to continue to be reused and circulate within an industry. So all of our materials are, for example, the mycelium. Mycelium are cannibals, so they will eat their own kind at the end of their life. So we could cycle that right back into its manufacturing process. With our old material, it's exactly the same thing. It can be crushed up and then turned into a new resource for the next batch of materials. If for any reason it ends up in landfill or is disposed of in a way that we would not choose to do, it's completely pH balanced, and it will actually offer nutrition to the soils and allow soils to regenerate. So it's understanding people's behavior and what could potentially happen and building that into the material development process is what's absolutely critical.
Yeah. Yeah, sorry, go ahead.
Point is that I think underpinning both of our presentations is also a kind of perturbance of the idea that the way in which we make things has to be the same. So one of the key questions I get asked all the time is, but bio-based plastics, for example, can't withstand the same long exposure to heat and temperature, and are not as stable basically over longer periods of time, which is what we need for a plastic. And I'd like to disrupt that a little bit by saying, perhaps the way we consume goods needs to be rethought as well. Like, for example, if we pair it with the local food movements or the movements around like how we grow and consume food in a much more regional approach, then we can think of packaging that actually relates to those more regional supply chains that make more sense. So I think we need to rethink a lot of things for this kind of material mix, and that should be exciting for sure.
Absolutely.
Yeah. And based on this insight, do you think there are more things we can learn from the biosphere for handling issues in the technosphere?
Go ahead, please.
Yeah, no, I think there's almost no limit to what could be learned from the biosphere and what could be implemented in the technosphere. I think as well as keeping them separated, it's also really important to look at, you know, more sensitive ways of incorporating the two. And when I say that, what I mean is we can find bacteria and funguses that are able to consume these materials that come from the technosphere or can process them in interesting ways. We need to do a lot more research before anything like that is actually implemented, because we want to make sure that we appreciate that at the end of that process, are those toxins still there? How they're going to be able to leach out into the environment and how that's managed. So I think there's absolutely an endless amount that we can learn and implement for sure. We've barely scratched the surface.
And I think one approach to that from an innovation standpoint is that, you know, if you look at the natural world and the way that materials are made, they're made out of a very small subset of elements in the periodic table, and those are assembled into building blocks that are repurposed again and again and again. But from those building blocks, which, you know, are carbohydrates, are proteins, are lipids, are common minerals such as calcium, silica, etc. Those simple set of building blocks create the most enormous biodiversity that is continuing to flourish and adapt and change. And so the idea that we are somehow limited just because we're using what's in the biocycle doesn't make sense. You know, the world is made plentiful by virtue of recombination. And so there is untold numbers, ways that you can recombine and reconfigure these building blocks to make amazing materials and amazing products.
Yeah, that's, I think, very true. And then somebody says, this is all about adding value with what we have and widening access. Can you prevent capturing by large businesses?
I think that's quite a critical question. I think it's interesting because it seems like both Biohm and Materiom have a more of a sort of developing a business model that will benefit the whole, that will benefit the wider communities. And when it comes to dealing with what we're working with in the commercial world, when you've got a technology that is truly groundbreaking or can actually have a lot of impact, you want to make sure that it's delivered and implemented in a very sensitive and ethical way. And that is always really difficult to do once you reach a certain level of scale. And that is because there are lots of interests that are currently in the industry that may not want that to become the mainstream. And it is a constant sort of battle, but the way we see it is not really a battle as much as a dance. We want to work together with those large multinationals, with the small companies, with government, with academia, to look at a new way of doing business that can benefit the whole. It's not about, you know, cutting profits so that you can share them with communities. No, it's about looking at profits in a very different way. You can still be profitable for the right reasons and implement your work or the fruits of your work in a way that is valuable for the wider community, while still having a comfortable and a good sort of future ahead of you. So I think it's just changing the narrative. Again, like Alysia said, with materials having to always overperform. We create materials that last hundreds of thousands of years and put them in buildings that only last 10 or 15 years. It's that same approach. We need to rethink our approach to economies and how we structure economies. When you've got that local resilience built up and the community being really powerful and resilient, when something like a pandemic, for example, happens, or when you're met with adversities, you can be much more stronger in your response. So it actually results in a much stronger, wider global economy.
The other theme on that front is what we are trying to do is provide a critical layer of information that will always be open and therefore fruitful for anyone who wants to invent and take that basic recipe and adapt it for their specific purposes. And that may be a company who takes it and, you know, provide and puts a patent on it for a specific high value application that they want to corner the market on. We can't prevent that, and that's not necessarily problematic either, because, you know, various ways of achieving innovation I think can coexist. But we think that in materials, that open source layer is missing. And so specifically on the bio side, you know, nature has open sourced the recipes, the source code of these materials for, you know, over billions of years, and we shouldn't, you know, take those and close it all off. So by providing that basic layer, it enables people to say, okay, for example, there's a mycelium recipe on Materiom that you can take and then adapt and optimize like Biohm has done, and then that's your proprietary, if you so choose. But you can always get in the game, and you can always start somewhere, and you can always understand and you know, start that innovation process from the local ingredients you have around you. And that knowledge needs to be much more widely disseminated, so that we can have more of an organic growth in this industry worldwide.
Mm-hmm.
Thank you. I think that's a very nice ending to our session, because it's already time, unfortunately. Thank you for sharing your insights, Ehab and Alysia. It was very nice.
Thank you, Marita.
And also, just one last practical thing. This indeed session will be made public on YouTube, so you will be able to find it there. And then I give the floor to Ken to close this day.
Yeah, I hope I'm unmuted now. Can you hear me?
Yes.
Yes.
Yeah, you can hear me now. Good. With a bit of delay. So thank you so much for that session. I always enjoy the sheer joy, in a way, of working in a biomimetic way, and the remarkable opportunities it offers. It's refreshing, because to me, it's one of the key elements of a circular economy, is to rethink materials and rethink business models, and to rethink the context in which these things operate. I like the point about why design a material to last thousands of years and fit it into a building that's going to last 15. It's, in a way, that the simplicity of the understanding is part of that strength of that. Well, I want to do a couple of wrap-up points at the moment. We're getting towards the end of our day, but immediately afterwards, for affiliate members, and remember, you can still join up for free, and for full members, we have a special session with the Ellen MacArthur Foundation team, who are going to have a sort of meet and greet around their work on data, their work on research and metrics. So it's particularly that element of it, and the opportunities that the Ellen MacArthur Foundation higher education team have to help you do the sort of networking that you would want to do. So that's a session at 1800 CEST, and you can find the link for that in the members area. Remember, it's not an IS4CE link, it's a Zoom link that the foundation have provided. So if you log into your members area, you can find it whether you're an affiliate or a full member. So that's, I think, a great opportunity for researchers and others to talk to people in the know, if you like, because the Ellen MacArthur Foundation has done a great deal of work in that direction. I have 2 or 3 things to pick up from today. Everybody's comments will be different, I imagine, and don't forget, send your thoughts and ideas through to info@is4ce.org. And some of the pickups for me is that circular economy is really at an inflection point, or a crunch point, somebody says. We're moving from the era of enthusiasm to one based on scientific knowledge, and at the same time, we're having to recognize, usefully that this is a systemic discussion. It's cross-disciplinary and it's very much dynamic systems. So anybody who wants to give you a list and say this is how it works, it's going to be a little bit disappointing, because that's not how the world works. It's a set of interdependent contingencies, if you like. It's a set of consequences. And so learning the best way to shape those, I won't say control them, the best way to shape those interactions is part of the challenge for a circular economy as a cross-disciplinary and systemic exercise. That's something to look forward to, in my view. This very systemic nature also brings with us the idea we have to work with uncertainty. And that also should be welcomed. Not only can we not entirely control these interdependent variables, but the bigger context, as we've discovered with COVID-19, is always likely to bring us surprises. And that means we have to put up with disappointments too. There's no magic mix for a circular economy. It's a work in progress. And having just seen the work with the Biohm and Materiom, it's so encouraging to see this sort of let's rethink everything sort of approach to the job in hand. And that brings me to tomorrow. We continue our sessions, closed sessions, from 5 to 11 in number, and that takes up the later morning and much of the afternoon tomorrow. So welcome if you're members and you're joining in. The next live session is tomorrow afternoon at 1600, when we have Swedish Industries Perspective. And we also have a panel session chaired by Walter Starhell, using the insights that the facilitators in the closed sessions have unearthed. And I think that would be very, very interesting, because all the facilitators are much more in the younger researchers or early career mode, whereas Walter is, as we said before, a bit of a godfather of this whole area, and that will be a very stimulating exchange, I think. And that's it for today. We have enjoyed our experiment in an international society inaugural conference, day 1. And what I've been most encouraged about is the degree of interest exhibited through this approach, this online adapted approach. And I must compliment the energy of members who not only did a conference paper, but roused themselves to produce an introductory video or audio. Emma and I went for audio since it seemed quite straightforward. But we had 90% of people submitted one. They didn't have to submit one because the paper was there, but it's really good to see we've got a whole archive of introductory material here for affiliated members and members to help them through the decision about which papers to read, unless of course you're one of these people who just has to read everything in full all the time. I think you probably get to a certain age when that gets harder to do, but you're very welcome. And I'd like to thank Matthias and Connie for being co-captains on this ship. I will do a proper run through of acknowledgements, but I also want to just say a quick word about Debs. Debs has been our administrator, website creator, manager, and all-round help to people who've been contacting through info@is4ce2020.org. And I don't know whether she's about to throw the laptop out of the window, but she's made it happen, and has been very, very happy to support your numerous inquiries. So I would also add that the volunteers who've been facilitators today and who will be tomorrow also deserve a degree of gratitude as well. Don't forget, drop me a line if you need to. You can find various videos and papers on the site, and Don't forget, you can always still join if you want to be an affiliate member to get access to lots of material. If you want to be part of the society and influence its future, we'll talk about that more tomorrow. Do consider being a full member when you will help shape the direction of this exciting area. Okay, from IS4CE, we're signing off for now, but don't forget Ellen MacArthur session in a few minutes. Okay, thanks very much, everyone.